In this and the next video, we will see how to use the recursion to solve a very famous problem, the Tower of Hanoi. So what is the Tower of Hanoi? So the first thing we know, the Tower of Hanoi is in 1883, a French mathematician. Yeah, I'm not sure how to pronounce that. But he invented a puzzle game they call the Tower of Hanoi. So that's why we have a city in Vietnam that called Hanoi. So what is the puzzle game? So this puzzle game, actually, you can win a lot of money. So this puzzle game actually tells you if you can fix this problem, you can solve this problem, you can win 34,000 in US dollar today. So this puzzle actually they talk about is you will consist few different discs. So though each disc they have the wood. So the original game they only have 8 discs. So they have a holes, so that's why in their center they can be piled in the order of the decreasing size on one pile. So for example, you see here we have 64 golden discs. So each disc actually they have different radius. So different radius, they always start from the smaller radius, then they pile down for the bigger one. So this puzzle game is when you try to move all the discs one by one to another, you will never place a larger disc on the top of a smaller one. So this game is you have the 3 pile. We begin with all the discs on one pile, from the small to large. So every time you only can move one disc to another. And also, between all the traveling to move the disc, the smaller disc always will be on top of the other. The smaller disc always on top of other bigger disc. So on the other hand, that's mean if you try to move the smaller one to here, right, to B, then you try to move the next one to B, then you will have a bigger disk on top of the smaller one. This one is not allowed. So this puzzle game actually offer you a prize for that time is a lot of money, equivalent to now is 34,000 US dollar. To anyone, if you can move a tower of the 64 disc by hand while following the rule of the game. So let's review the rule again. So the rule is you totally have the n disc. So you would label they are 1, 2, 3, 4 until 64 for this case. And you have 3 towers labeled A, B, and C. So all the discs are initially placed on the tower A from small to large. So no disk can be on top of a smaller disk at any time. So that's the rule. Then anytime when you want to move the disk, you only can move one disk at a time. So that means it only can be the smallest disk on a tower. So now, do you think you can do that? You will win $34,000. So in order to help you to practice, here is the link. You can play with the Tower of Hanoi again. So after you open this website, so you can see here, we just start from, you can change, or they only allow you to do 3. So we can start from 1. You see, if you start from 1, right, you always just move 1 to the other one. So then you are okay, right? So then we restart. So since we need to do 2, right? So if you want to do 2, you see you have 1 here, then 2 here, then another 2, another 1 here. So then we can move the 2 discs, no problem. But now you see here, how about the 3? So right, so when we do the 3, you see we need to move the 3 here, then the 1 here, then the second one, then yeah, we solve the problem. Okay, but this scan is a little different. In this video, they show you they start from A, but their target tower is B. But in my handout, my target is C. But doesn't matter, you can play with that to show how to do that. So now you see you can successfully to move the 3 disk to the destination, right? So then continue. Can you do 4? Can you do 5? Can you do 6? So you can play with that. But one thing is how we will solve this problem. We will just see from earlier our result. We can think about its recursion function because we can move 1 to the destination. We can try to move 2 to the destination. And as earlier, like I showed you, I successfully to move the 3 to the destination because my destination is this one. So you see my 3 to move to here. That means I prove you I can move 3 disks to the destination. So on the other hand, whenever we want to do one more, I just need to have this 3 to the other one, right? Okay, so that's why you see here, I finish my 3. So since I can move the 3 to the other tower, so then the last one, I just have the biggest one to the destination. Then I can continue to do what I should do. So then you can see here, restart, we should do here, right? So then you move that to here. So then this one to here. So then you see your search can come here. Done. Okay, but here actually they show you the minimum move should be 15 because earlier I do something wrong, so that's I have 16. Okay, so anyway, let's come back. I want you to spend time to play with that. But the most important thing when we do the Tower of Hanoi from here, the practice, we find out what? We find out actually we can using this one, like we say the like recursion function. You can see the handout here. The same thing is from the website, how they play. So I want you to try to see how you will play. But the most important thing is after I show you, we find out since I can move 1 disk, I can move 2 disks, I can move 3 disks. So on the other hand, I already proved you I can do that, right? So actually for any n disk, as long as your n greater than 1, we can split this original problem into the following 3 sub-problems. And we can solve them sequentially. Because if you want to move the total n disk to the destination, right? I just need to find a way to move the first n-1 disk from A to C recursively with the assistance of the tower B. So then after we're done, I just move our n disk from A to B if we say B is our destination. So then you see the rest of the n-1 disk from C to B, we can just recursively to do the assistant using the tower A. What does that mean? That means from here. You see, even now, you see we restart. We do 4 already, I show you, right? So when I do the 5, if here the B is our destination, earlier I already showed you I can successfully to move 1, 2, 3, 4, 4 to a destination. So I just found a way. Earlier I repeat my action to move the first 4 to this location. Then you see the 5 will be the last one, right? So then I move this 5 to my destination. Then I just need to consider I don't have the 5. So then you see earlier I can move 4 from A to C. So then later can I still move the 4 to the C to B? So then you see I have all the disk move. Because of course I show you I can move 1 disk. So then I can move 2 disks. So then I can move 3 disks. So then as long as I finish the 5, I can show you. Then I just need to repeat move the disk 5 to the destination. Then your 6 go to the final destination. Then the rest of 5, I just repeat what I do. So that's our recursion operation. Whenever you have n, you just need to repeat the first n-1 from the original location to the assistant location. Then you move the last one to the destination. Then the rest of that, we just repeat. Right? So on the other hand, it just means I only need to write a function. This function means I can move the Tower of Hanoi for n. Then in order to solve the Tower of Hanoi for n, I just need to call the recursion function. The same function I call that, but I pass n-1. Then, do you know how to move the disk n from A to B? Right, you can, right? You just move. So then again, I just call the Hanoi, Tower of Hanoi function again. Then I move the n-1. So then that's the recursion function. So what is the function prototype for the recursion function? So yeah, here actually is what I told you earlier. Yeah, your original position like this. So then we just need to find a way to move n-1 to the to the existing location. So then I move to the destination. So then afterward, you see the biggest one to the final destination. The rest of that can go there. So that's also the same picture, show the same concept. But the most important thing is when we have our function I call move disk. So this move disk can help me to solve the Tower of Hanoi problem. So then, of course, earlier we say you need to pass your n. But only pass n is not enough. We also need to know the label for each tower. So that's why we have the 3 characters also passing to the argument. The first character is the front tower, where all the disks start. Then the second parameter is your final destination for all the tower. So then your last one is the assistant tower. So for example, you see you want to move n from A to B, right? So then you will call this move disk function. So then you pass in the n. So then A will be your front tower. B will be your 2 tower. Then C will be your assistant tower. So that's our move function. To move n disk from front tower to the 2 tower with the assistant of the axis tower. Yeah, so that's our recursion function. So how will you implement this recursion function for the move disk? So I will just stop the video for now. Then you can think about that before you move into the next video. Before you see my solution, you should try to implement this recursion function yourself first.